So you might be wondering how you're supposed to answer this particular question. What is that thing right there? The limit as h goes to 0 of the difference quotient. Why is that the derivative of a function? Well, it's the derivative of a function because, number one, a derivative is the rate at which something changes. Okay, the derivative, and let me write that down. Derivative equals the rate of change. And in fact, it's not just the rate of change, it's the instantaneous rate of change. It's the rate of change at a particular moment. And in terms of the graph of a function, if we look at the graph of, let's say this is f of x, okay, so y equals f of x, and we isolate one particular point. If we want to figure out what in the world the slope of the tangent line is right here at that point, we want to figure out that slope. Okay, so that's our goal, is to find the slope of that tangent line. So m equals, we don't know. Okay, in the past we have found slopes of tangent lines in which, or sorry, we found slopes of secant lines, but we were given 2 points on the graph. Okay, and the 2 points on the graph, that's fine. We can actually draw a line through those 2 points, and it's easy to find the slope of that particular line because we have 2 points. It's just rise over run. Well, that's where we get this expression from. Here we have our x, here we have our x plus h, and we can see that the coordinates of this point right up here are x plus h, comma, f of x, that's not very clear, sorry, comma, f of, let me see if I can fit that in, x plus h. Okay, well, let me get another parentheses there. And then down here, this particular point on the green line has coordinates x, comma, f of x. Okay, and so the bottom line is this difference quotient. I'll just go ahead and circle it in green. So I'm going to circle this. This guy right here is so this is what you'll want to say in your definition or your explanation. This is the slope of the secant line. Okay, that's the slope of the secant line because it's the change in y, which is f of x plus h minus f of x. That's the change in y, the rate at which y changes, or I should say the difference in the y coordinates. And then this h down here, well, the h is the difference in the x coordinates, and the difference in the x coordinates would be x plus h minus x, which is just equal to h. That's why we have just an h down there. Okay, so the difference in the y minus the difference in the x, or divided by, I should say, divided by the difference in the x. And so the slope of the secant line is what we start with, but as we take the limit here, so again we're going to find the limit as h goes to 0. So what does that mean? Well, the h is represented by this distance between x and x plus h. So that's h right there. As h gets closer and closer to 0, the gap between x and x plus h gets smaller. And then meanwhile, while the gap gets smaller there, this other point along the curve gets closer and closer to the point over here. Now let's call this point P. Okay, so point P is right here, and let's call that point Q up there. So point Q gets closer and closer to point P. And as Q gets closer and closer to point P, the slope of the secant line approaches the slope of the tangent line. And so the slope of the green line gets closer and closer to the slope of the red line as h gets closer and closer to 0. And so therefore the derivative represents the slope of the tangent line because it's the limiting value of that slope of the secant line. So that's basically it. It's the limiting value of the slope of the secant line, and as h goes to 0. That's the definition, or that's the explanation for why this big, ugly definition of the derivative is the derivative of a function. Okay, so hopefully that will help you. I didn't write it all down, but If you want to replay that and write it down yourself and then study that, that would be probably a pretty good idea. And I'm going to pause it and see if there's anything else I need to answer for you guys. This would be problem number 3, kind of towards the top. There, the top part of this study guide, part 2. Okay, so this is a non-book problem. This is just a problem that I said you need to know how to do. In problem number 3, you're supposed to try to find the derivative of this function, f of x equals 1 over x, but not using the power rule, but using the definition of the derivative. And so the definition of the derivative was what we just talked about. It's the limit as h goes to 0 of f of x plus h. Well, f of x plus h in this case is 1 over x plus h. Okay, minus f of x, which is 1 over x, divided that all by h. Okay, so well, there's the using the definition of the derivative. And we did a problem, I just did a problem like this, and I believe it was on, I think it was problem number 5 on page 91, so refer to that. Refer to either 1, 5, or 10 on page 191. I'm pretty sure it's number 5. I might have said 191, but and I'm looking back right now. It is problem number 5. See problem number 5 on page 91. See number 5. Okay, page 91. All right, and so it basically, to figure out what this limit is, we have to set h equal to 0, and when we do that, we get 0 over 0. When we get 0 over 0, there's a technique. What we're going to do here is we're going to multiply top and bottom by the same thing, and that same thing happens to be the lowest common denominator. I was trying to listen to my wife and daughter in the other room here. Lowest common denominator, and when we do that, we can see again, I'm not going to show all the detail here because I just showed it in problem number 5 over there, but when we multiply this x times x plus h, multiply by both of these terms in the parentheses, what we get is x minus x plus h. We get that in the numerator, and then I'll reiterate this, don't multiply these out, because what you're hoping is that this x right down here is going to cancel. And hopefully we can see that that does happen here. We got the limit as h goes to 0, and we're going to go ahead and let's not do that. Okay, I'll just go ahead and do this one last step here. X minus h. I just distributed the minus sign, and then we can see that in the numerator the x's cancel out, so we still have the limit as h goes to 0 of negative h excuse me, over h times x plus h. Well, we can see here that the h's cancel, and now all we have to do is plug h back in. H equals 0 back in. And so we have, this is negative 1 up on top, so we have negative 1 over x times x plus 0. And we know that x plus 0 is x, and negative 1 over x times x is negative 1 over x squared. And you can easily verify, guys, when you get this problem on the test, just, take some time and use use your rules just to see if you got the right answer. It's amazing how many students will leave that answer wrong when they could just verify. If f of x equals x to the negative 1, then f prime of x equals negative 1 times x to the negative 2, which is negative 1 over x squared. So you're allowed to do that to check, and check, just it's the same thing. And so you know how to do this using the power rule, and so I'm just asking you to make sure you remember how to use the definition of the derivative to find the derivative of a function. Okay, and I think I'll go ahead and scoot on over here to number 4. Number 4, at the top of this study guide, number 2, says we're supposed to find the equation of the tangent line to the graph of f when x is 2 for this function f of x equals, okay, so this is a pretty quick one, f of x equals 2x squared plus 4x. Okay, well, f prime of x, let me do this in a different color, we first have to find the slope of the tangent line. 2 times 2x plus 4. So we have 4x plus 4. Okay, so that's the slope of the tangent line at x, but what we really want to know is what's the slope of the tangent line when x is 2? Well, 4 times 2 plus 4 gives us 8 plus 4, or 12. So that's our slope. And we want to know what the when we want an equation of a tangent line, we want the slope, which is 12, and we also want a point. And the point xy is 2 for x. Well, now what's the y? Well, I get this question a lot. It's interesting because back in Algebra 1, if you wanted to know the y, you plugged in the 2 to get the y. And so we do the same thing here. It's just kind of interesting how when students start learning derivatives, they forget how to find the y coordinate. The y, that's f of 2. Okay? So I didn't like the way I wrote that 2. So f of 2 is the y value. Well, what is f of 2? Well, f of x is 2x squared plus 4x, so therefore f of 2 must be 2 times 2 squared plus 4 times 2. Okay, let's not forget the stuff that you learned back in Algebra 1. So we have 2 times 4 plus 4 times 2, so we have 8 plus 8, or 16. Okay, so 16 then is the y coordinate. So if we want to know what the equation of the tangent line is, it's y minus the y coordinate equals, and the slope again is 12, 12 times x minus the x coordinate, so x minus 2. And that's it. That's the equation of the tangent line at x equals 2. So we had to do a little bit there. Okay, I'm at 12 minutes. Do I have to do anything else? 23 on page 131. Let me see if I can get that in here. I just looked at the problem. What I'm going to do is I'm going to make a new video for number 23 on page 131.